Hello, you're welcome back. Okay, so we're still on matrix and we are looking at the cofactor of 3 by 3 matrix. Okay, so here we're going to be solving an example. So I have a matrix here before me. Okay, so I'm to evaluate the cofactor. So now for me to evaluate the cofactor of this matrix, you know very well that I have to get the minor of each of these elements, okay, along with their place value. All right, so let's start with the minor of the very first element, which of course is a11, right? So you know how that's gonna be. So that's gonna be minus 1 multiplied by 1 plus 1. Okay, 1 is the position of both the row and the column, right? Then of course times the determinant of is minor. The determinant of is minor, right, is of course when you cross the row, cross the column, what you have left, that's gonna be 2, 1, 2, and 4. Okay, so that's a11. Then of course let me do a12. Of course you know how that's gonna be. That's gonna be minus 1. All right, the rest of 1 plus 2 multiplied by its corresponding determinant. Cross this column, cross this row, you're left with 3, 1, then 1 and 4. Okay, let's go to the next one. Okay, let's look at a13 now. Okay, so there's gonna be minus 1, rest of the power of 1 plus 3, multiply by cross this, I'm having 3, 2, 1, 2, comma, then I'm now coming to a21. This is going to be minus 1. Okay, then 2 plus 1 multiplied by each matrix, cross this, so I'm left with 1, 1, 2, 4. Okay, comma, let's look at a 2, 2. That's minus 1, rest of the power of 2 plus 2. Then of course the matrix, cross this, so I have a 2, 1, 1, 4. Okay, so let's get to the next, a23 minus 1. Okay, so let's do that. Cross this, I have 2, 1, 1, 2, comma, next okay, a23, right? Okay, so now I am now at a31. Okay, so of course this is 2, 3. This is 2 plus 5. Okay, so let's do that. Of course this is gonna be minus 1. This is power of 3 plus 1 multiplied by cross this, have 1, 1, 2, 1. Okay, a 3 2 minus 1 raised to the power of 3 plus 2. Cross this, you're left with 2 1 1 1. 2 1 1 1, comma. Okay, so finally I have a 3 3. That's minus 1 minus 1 raised to the power of 3 plus 3. Okay, you know what we do? Cross this. Have 2 1 3 2. All right, so that is all of them. So we now write their values. Okay, so the cofactor now. Cofactor of A is going to be equal to. So I want to pick their value and write them. Okay, so I can actually do that in a rough. Of course, this of course it will be positive. Minus 1 raised to 2 is positive. So I'm going to have 4 times 2, 8, then minus 2, that's 6. So what I'm having here is going to be 6. Okay, let's do this. Of course, this will be negative. This minus 1 raised to 3 is still minus 1. Then let's look at the determinant. This is 12 minus 1, 13. So here, what I'll be having is minus 13. Okay, let's look at this. This is positive, right? Of course, it goes positive, negative, positive. So I don't even need to check this, and I know the sequence now. Okay, so this is positive. Okay, so multiply. This is gonna be 6 minus 2. 3 times 2 is 6, then minus 2, which of course is 4. That's what I'll be having here. Okay, let's look at this. Negative, that's what it's gonna be. Odd. 4 minus 2, so that's gonna be minus 2 that I'll have here. Let's look at this. Positive. 6 minus 1. Okay, that's gonna be 5. Let's look at this. Negative. This will be negative. Of course, this is supposed to be plus 3. 2 plus 3, not 2 plus 5. Okay, so can correct that. 2 plus 3. Okay, all this time is still gonna be negative. Okay, so what is it gonna be? This 4 minus 1, which of course is 3. Okay, so let's look at this. Positive. Yeah, this is negative. Minus 3. Okay, so now let's look at this. Positive. This is going to be 1, then of course minus 2. 1 minus 2 is minus 1. Let's look at this. Let's look at this. This is going to be negative. 2 minus 1. Okay, that's going to be minus 1. Now let's look at this. This is positive. This is 4 minus 3, which is 1. So that is, so my cofactor is 6 minus 34 minus 2, 5 minus 3 minus 1 and 1. Okay, so that is how we evaluate cofactor of 3 by 3 matrix. I hope that is well understood. Okay, so let's proceed. So another thing we also need to evaluate, okay, on matrix is known as the adjoint of a matrix. The adjoint of a matrix. So that's adjoint of a matrix. So how do we evaluate the adjoint of a matrix, or what is the adjoint of a matrix? Now it's simple. The adjoint of a matrix is simply the transpose of the matrix cofactor cofactor. For example, okay, if I have matrix A, okay, let's say if the cofactor of matrix A is given as another matrix, okay, which of course is A11, as we already know, A12, capital letter A13, A21, A22, A23. Here I have A31, A32, then A33. Then I'm to actually find the adjoint of this cofactor. All right. So which simply means that before you can find the adjoint of a matrix, you must first of all evaluate its cofactor. So the adjoint of matrix A now, adjoint A, is going to be the transpose of this cofactor. And of course, you know how we transpose a matrix. Okay. By transposing a matrix, we exchange the rows to column. So that means the first column now becomes the first row. So what I'm going to have is A11, A21, then A31. Second column becomes the second row. That's A12, A22, A23. The third column becomes the third row. So now that's going to be A13, A23, then A33. So that is how we evaluate the adjoint of a matrix. So please take note of that. All right, now we still gotta look at another operation on the matrix. Okay, it's known as the inverse of a matrix. Okay, all right. Now let's say we are to evaluate the inverse of a matrix. Let's say A inverse. I use that to represent, okay? So inverse of a matrix A. All I just need to do is divide the adjoint of that matrix, the adjoint of the matrix, by the determinant of the matrix. As simple as that. Okay? Then I can illustrate this using just a 2 by 2 matrix. Okay, let's illustrate this. Okay, so the question is, let's say you are being asked to find the inverse of matrix A being equal to 3, 2, 1, 1, 4. Okay, solution. Of course, you know the very first thing you're going to do is you have to find the cofactor. So looking for the cofactor of 2 by 2 matrix is just very easy. Okay, so cofactor of A, of course it's going to be equal to their place value. Okay, the place value of their minor. The minor of 3 is 4, right? And of course the place value is at even 1 1. That's gonna be positive, right? Okay, let's go to this. The minor of 2 is 1, and of course this is 2 row 1 column 2. That is odd. Okay, so here that's gonna be -1. Then let's get to this point. The place value of 1 here is 2, and 2, this is at odd position. This one here is at odd position. Of course that is row 2 column 1 odd, so I will have to put minus, okay, to the minor. Then of course the place value of 4 here is 3, okay, and it's positive. It's at even position, positive. So that is, then the next thing I'm going to do now is to get the adjoint. Okay, so the adjoint of A is simple. The adjoint of A is simply the transpose. So let's transpose this. So the first row becomes the first column, -2. Oh, please pardon me, not -2. First, 4 before -2, 4, then -2, -1. Okay, then I have 4. Okay, so I haven't gotten the adjoint now. Remember, for me to be able to get my determinant, I must get my inverse. I must evaluate the determinant of this matrix. Okay, of course, you know how we evaluate the determinant of the matrix. Please, first, this is okay. I have to use the symbol of matrix there. Even for cofactor, I have to use the symbol of matrix. So please correct that. Okay, so I only use symbol of determinant when I'm evaluating determinant. So now I want to evaluate the determinant of this. Of course, you know how we do it. Okay, major diagonal, that's 3 times 4, that's going to be 12, minus the minor diagonal 1 times 2, that is 2. So when I subtract that, that's going to give me 10. Okay, so combine everything together. A inverse, now you know how it is. That's going to be the adjoint of A, then divided by the determinant of A. So let's do that. So that's gonna be 1 all over the determinant, then multiply by, because whenever you are dividing a matrix by a single value, okay, the same thing that happens whenever we multiply matrix by a single value. Okay, we'll multiply all the elements by that single value. The same thing happens here. If I divide a matrix by a single value, so we divide all the elements of that particular matrix by the single value. Okay, so the matrix now, the adjoint, that's 4 -2 -1, then of course 4. Did I make mistake somewhere? I'm having 4. Okay, I shouldn't have 4. Shouldn't repeat itself. The cofactor of this is not 4, rather is 3. Okay, please correct that. So what I'm having here, okay, so when I now do this, gonna be 4 -2, 4 -2, then -1, 3. Please correct this. Okay, so because the minor of 4 here is 3, correct that mistake. Okay, so also correct that mistake here. So I'm having 3. Okay, so let's now finalize our answer. So let's evaluate that. So that simply means that my inverse now, A inverse, is going to be equal to 4 all over 10 minus 2 all over 10 minus, okay, minus 1 all over 10, then 3 all over 10. Okay, so you can still break it down. 2 go into 4, 2. Go into 10, that's 5. This is going to be minus 1 all over 5. This is going to be minus 1 all over 10. And this is 3 all over 10. Okay, so that is how we evaluate the inverse of a matrix. Okay, now finally let's look at the application of the inverse. Okay, application of the inverse of a matrix. Now, if we know how to evaluate the inverse of a matrix, it will also enable us to solve a typical linear equation. Okay, it will enable us to solve a typical linear equation. What do I mean? That is linear simultaneous equation, right? Okay, remember what we had before? That's ax plus by equal to c being equation 1. Then of course, okay, we use this a1, please pardon me, a1x plus b1y, okay, is equal to c1 equation 1. Then of course, a2x plus b2y equal to c2. Okay, so now I can solve this matrix applying my knowledge of the inverse of a matrix. Okay, how will I do that? Let's actually, I'm going to reduce this matrix into I'm going to use x to represent the entire variable. Okay, then I use capital letter A to represent the coefficient of the variable. So this equation can actually be reduced in a form of a matrix multiplied by its variable, then equal to the constant c. So invariably now, if I want to get the variable x, okay, that is going to be, I'm going to do 1 all over a, okay, multiplied by c. So this 1 all over a is equivalent to the inverse of a. Of course, you know very well that in mathematics. So it's the same thing as actually getting to do the inverse of a, then multiply by c. So now how is it applicable to this? How can we transform this to this? All right, so I'm going to separate this into component matrix. Okay, this particular equation that can be separated, the constant value can be separated. So I'm going to use 2 by 2 matrix, okay, for the constant value. That is a1, please pardon me, a1 b1, okay, h2 b2. Then I now multiply it, remember, okay, this is the coefficient, then multiply it by the variables. And of course, since the variables is just 2 variables, so I'm using 2 by 1 matrix, okay, 2 by 1 matrix, which of course This is x and this is going to be y. Then of course equal to my constant value. My constant value is just still 2, all right? So I'm still going to use 2 by 1 matrix. So that's going to be C1, C2. So with what I have here now, okay, it is very much easy now for me to get my matrix x y, okay, get the value of the s of my unknown xy. How will I do that? So invariably now for me to get the value of my unknown x y, okay, in form of 2 by 1 matrix, all I just need to do, I take this this matrix 2 by 2 matrix to the right side of the equation, but it will go there as an inverse, okay? So it will be a1 b1 a2 b2, okay, then inverse, then multiply by c1 c2. Okay, so this is a basic application. Apart from the Cramer's rule, this is another way of solving a linear simultaneous equation. It's another way of solving it. Okay, let's look at a typical example. Okay, let's look at typical example. Okay, let's look at a situation where you're being given. Okay, let me see if I can pick some question from somewhere. Okay, let me go ahead and just set one. Okay, using matrix. Okay, solve 2x minus y is equal to 1, then x plus 2y equal to 2. Equation 1, equation 2. Okay, so how do we do this? As simple as possible, I split my matrix into component. The coefficient, which of course is 2 minus 1, 1, then 2. Okay, then multiply by my variable xy is equal to my constant value. So invariably now, for me to be able to get my xy, all I just need to do is to evaluate the inverse of this matrix. 2 minus 1, 1, 2, okay, inverse, then times the constant value 1. So now the whole work now actually arises, okay, from evaluating the inverse of this matrix. So let me call that matrix A, so that I can evaluate the inverse. Okay, so I will select the matrix. Let the matrix there be A, okay? So let A be equal to 2 minus 1, 1, 2. Okay, so of course, you know, the very first thing we do, we have to start with the cofactor of A. You know how we do the cofactor, okay? This is positive, right? The minor, and of course this will be negative. So since this is already negative, there's minus 1 already. Okay, the minor, okay, no, this is actually the minor of minus 1 here is 1. Okay, then of course the minor of this minus 1 is 1, and of course it's at the odd position, that's minus 1. And of course the minor of this 1 is minus 1. It's also at the odd position, it's minus 1. Now don't forget that minus times minus, okay, because here I will have minus times minus 1, which of course makes this one to be plus 1. Okay, the minor of the 2 I have here is also 2, and this at even position, so it's still gonna be 2. Okay, so that is a cofactor. Then of course the adjoint of A, you know how we do that with transpose. Okay, that's gonna be 2 1, then minus 1 2. Okay, so the inverse now, we do the inverse. So inverse is gonna be equal to, let's do that. Okay, so we are dividing the determinant. First of all, let's get the determinant of our matrix. So what's the determinant of our matrix? Okay, so the determinant is 2 times 2, which of course is 4, then minus 1 times minus 1. Minus into minus is plus. Okay, I hope you know that this is going to be minus into minus 1 times 1. Okay, you know very well that that is going to give us plus, so that's going to give us 5. Okay, so invariably now my inverse now is going to be equal to 1 all over 10. Okay, then multiply by the adjoint, which of course is 2 1 minus 1 then 2. Okay, let's flow. Okay, so with what we have now, I've gotten my inverse, but I have to simplify it. Okay, let me simplify it. So this is going to be 2 all over 10, which of course is 1 all over 5. This of course is 1 all over 10. This is going to be minus 1 all over 10. And of course this is 1 all over 5. Okay, so here we are with our inverse, so we can now return back to this. So to get my x comma y now, to get my unknown, x comma y, all I simply gotta do is to multiply my inverse, a inverse, which of course is 1 all over 5, 1 all over 10, minus 1 all over 10. Okay, 1 all over 5 by the 2 by 1 matrix, okay, of the constant values 1 comma 2. So let's do this multiplication. Okay, so let's do this multiplication. So x comma y, of course you know how we multiply matrix. Okay, row against column. So 1 all over 5 times 1, that's gonna be 1 all over 5, then plus 1 all over 10 times 2. Okay, let me just do that. 1 all over 10 times 2, so that you know where I'm coming from. Okay, so this row have finished multiplying this column, then the second row, okay, we still multiply this column. And of course I'm not going to just put it, I'm just gonna it's just going to be a column matrix. Okay, a column matrix. So instead of making it a row, I'll make it a column matrix so that it will be equivalent to this. Okay, so let's go minus 1 all over 10 times 1 will still give me minus 1 all over 10, right? Okay, so then of course plus 1 all over 5 times 2, that's 2 all over 5. Okay, so invariably, let me just do this. This is gonna be 1 all over 5, or better still, so this is 1 all over 5, so that I will not have to go through lengthy simplification. Okay, so here we go. LCM is 5, right? So if I should simplify this fraction, I'm going to have 2 all over 5, right? 2 all over 5. Yeah, this is going to be 2 all over 5. And of course, if I should simplify this fraction, the LCM, of course, is 10. 10 divided by 10 is 1. 1 times minus 1 is minus 1. 10 divided by 4 by 10 divided by 5 is 2. 2 times 2, that's 4. So I'm having minus, please, 10 divided by 5 is 2. 2 times 2, that's 4. So minus 1 plus 4, that's going to be 3. 3 all over 10, okay? So what I'm going to have here is 3 all over 10. So I can now get my x, okay, by equating, of course, equivalent matrix, okay? So if this 2 by 2 matrix, 2 by 1 please matrix, okay, are equal, it simply means that their positions element are equal. So x, y, 2 all over 5, then now 3 all over 10, okay? So that simply means that x now is going to be equal to 2 all over 5. And of course, my y is going to be equal to 3 all over 10. So that is how we, okay, solve a system of linear equation using matrix. Okay, so please take note of all this. And of course, we are going to solve more questions, okay? So I will give you the opportunity of, okay, going through what you've already treated, and when you're done, we'll continue. All right, see you in the next video. Thank you very much.